Hey guys, and welcome back. Today we are continuing our lessons on matter. So far we've learned how to classify matter either into our colloids, suspensions, compounds, or elements, and we've also talked about the difference between chemical and physical changes. So today we are moving on to talking about types of matter, specifically how to identify the difference between metals, nonmetals, and metalloids. And we're also going to get a little bit of an intro into our periodic table. So let's go ahead and jump right into it. Oh, went too far. So we've already talked a little bit about the difference between elements and compounds when we talked about classifying matter, but just to make sure we're all on the same page, chemical formulas for elements are 1 or 2 letters long. So hydrogen would be H, chlorine Cl, carbon C, oxygen O, gold is Au, etc., etc. And all of these elements are found on the periodic table, which is this picture right here. And we're going to get very familiar with our periodic table over the course of this semester. Chemical formulas for compounds contain element formulas as well as numbers indicated for the number of atoms in each. So we've talked about water so far, which would be H2O. So that's 2 atoms of hydrogen, 1 of oxygen. Sodium chloride, also known as salts, would be 1 atom of sodium, 1 of chlorine. And then ammonia would be 1 nitrogen and 3 hydrogen. So we're going to get to know these formulas and how these formulas come about a little bit later on in this semester, but for now we're just getting a quick intro to the periodic table. It has these elements, so each box on the periodic table is an element, one single element, so that would be your pure substance, and then compounds would be 2 or more of these elements bonded together, okay, and that's really the nitty-gritty of what you need to know about that right now. So the periodic table provides a graphic organizer of the characteristics of each element. There are a finite number, so we've discovered the elements, the ones that are on the table, that's how many there are. Everything in the world is made up of those elements. And there are similarities among groups of elements. So if you think about yourself and kind of, like your friend group, a lot of times groups in high school, cliques of students, they come together based on their similarities. Like maybe you're friends with people because they have similar interests as you, or you all have the same hobby. That's kind of a similar idea of how the periodic table is grouped. They're grouped based on their similarities in their properties. And it helps us predict how elements will react with each other as well. So I have a link here to p-table. I'm going to go here really quick just to show you. We're going to be using this a lot in here. It's very, very helpful and very easy. So this is just another look at your periodic table. I like this one especially for you guys as virtual students because when you hover your mouse over it, it shows you the element and it shows you all the information about that element as well. It color codes it for you. It gives you their groups. And it really is just a really great tool that we're going to be using. Now we're going to talk about these groups and what like all these numbers mean a little bit later on. But for now, this is just what your periodic table looks like. When you hover over an element, you see the name of the element. So this is helium. And then you see its atomic symbol too. So it's just He right here. Which is just the abbreviation for helium. So we'll be using this. You guys are going to do a little bit of a scavenger hunt with this today, but this is going to be a really great tool for us in the future. All right. So let's talk a little bit about how we can use the periodic table. So the first thing we need to know is what are the periods. So the periods are the horizontal rows, and they go from left to right. Okay. Now the elements in a period, they have a range of properties, so they have different properties. So they're not necessarily related if they're in the same period. So the way that I remember the periods is that you put a period at the end of a sentence and we write from left to right. So like when you're reading, you would start from the left and you would read towards the right. And then of course a period goes at the end of the sentence. So that just helps me remember that the periods are the horizontal rows. So, and these are just numbered starting at the top with 1. So this would be period 1, period 2, period 3, period 4, all the way down. Okay, so we just need to know that periods go from left to right. So if I were to ask you, what are the elements in period 3? You could just come to your table, and like here, they're highlighted in yellow. There's not actually information on here because it's just showing you the outline of the table. But any of these elements that are highlighted in yellow, you could tell me are in period 3. Groups and families are going to be the vertical columns, so the ones that go up and down. And this is where we start to group them based on their chemical properties. So if you are in the same group or family as another element, then those elements have similar properties to each other. So I like to remember them as families because if you think about your own family, you share genetics, you're all a little bit similar. So you yourself are your own unique person, but because you come from a family with the same genetics, you all have variable similarities. So like I have a bunch of siblings myself. We all look different. We're all our own unique individuals, but we do have some similarities based on our genetics. So that's just a really good way to help me remember. So periods go from left to right. Groups or families go up to down or up and down. And the families are the ones where we get those similar characteristics for the elements. And here are groups and families that we're going to get familiar with during this class. So the groups and the families have their own names. You don't have to memorize them. As you start to practice, you'll start to remember some of them, but you can always use this as a reference as long as you know how to identify the correct element. So if I told you to, find hydrogen, if you could find hydrogen, as long as you can make the connection that hydrogen is in this first family here and that first family is an alkali metal, you should be able to tell me, oh, hydrogen is an alkali metal. That's the extent of what you guys will need to do. Just be able to correctly identify the correct family that they're in. So group 1 are the alkali metals. 2 are the alkaline earth metals. This middle block right here are the transition metals. Then we have our boron group, our carbon group, our nitrogen group, our chalcogen group, our halogen group, and our noble gases. And now remember, if these elements are in the same group, they're going to have similar properties. So like, for example, beryllium and magnesium here, these are both alkaline earth metals, so you would expect those elements to have similar properties. Okay, so these are the groups and the families. Again, right now today, all you would need to be able to do is find the element and tell me just the name of the group that that element is in. And then down here we have our lanthanoids and our actinoids. These actually go up here, so we take them out of the table and put them at the bottom to keep everything kind of neat, and it allows us to see the table as a whole. But if we were to pluck these up and put them back in the table, they would fit in right here. So it would be just an extra long table, and that's not really very conducive to putting it on a slideshow. So here is a color-coded periodic table related to what we're talking about today, which are metals, nonmetals, and metalloids. So on the periodic table, we have elements that we can classify into different groups based on their properties. And now our metals are going to be on our left-hand side of our table. So if we look at all the elements that are shaded blue, those are going to be metals. If we look here, this is called the stair step of the table. These are all the green elements right here. These are metalloids. And then where you see yellow, yellow is going to be our nonmetals. Now if you notice hydrogen over here, he is in group 1, but he's color-coded as a nonmetal. He's special. We'll talk about him a little bit later. He's special because he's got one valence electron but he is a nonmetal. So when you guys are identifying nonmetals, even though hydrogen's on the left-hand side, he is a nonmetal. So we got to remember he goes with the nonmetals. So what is the difference between metals, nonmetals, and metalloids? Metals are good conductors of heat and electricity. They have a high luster, so they're very shiny, and they're also ductile and malleable. Now, if something is ductile, it means it can basically be molded into a wire, so pounded into a wire, so think of like copper wire. And malleable just means the metal can be pounded into a shape and it will retain that shape. So metals are good if you think about metal coins, copper wiring, all that good stuff. Those would be metals. Nonmetals are poor conductors of heat and electricity, and they tend to be dull and brittle. So this is going to be things like oxygen that we breathe in the atmosphere. We're not breathing in metal from oxygen. Oxygen is a nonmetal, typically exists as a gas. And then metalloids are kind of the elements that are in between. That's why they're located in the middle of the periodic table. They're on that stair step. So typically these have properties that are similar to both metals and nonmetals. So they're in between, so they're located in between on the table. They're typically mediocre conductors of electricity, so aka also known as semiconductors, which means they could conduct electricity, but not nearly as good as those metals do. And here again, I just wanted to bring back this periodic table. So again, in the blue we have our metals. So any of these elements here that are shaded in blue, like calcium, magnesium, sodium, potassium, iron, cobalt, all of these metals would have those properties of metal. So good conductors of electricity. They're ductile. They're malleable. All of these metalloids, so boron, silicon, arsenic, all of these in the green, they would have the properties of the metalloids, so the in-between semiconductors. And then our nonmetals, so fluorine, oxygen, nitrogen, sulfur, all these in yellow, those would have those non-metal qualities. So poor conductors of electricity. A lot of these exist actually as gases. So they are non-metals. Okay. So today, the biggest thing I want you to take away is number one, being able to identify the different periods and the different groups of the periodic table, and then also being able to identify whether or not an element is a metal, a non-metal, or a metalloid based on its position. Okay, so you'll always have access to this color-coded periodic table. So when you pull it up, if you can identify the element, where it's located, then you should be able to tell me what type of element it is. Okay, so you guys are going to do some practice with that, as well as some practice with the groups and the families in today's assignment. But if you have any questions, of course, you guys know you can always reach out and let me know. And that is it for today, and I hope you guys have a great one, and I'll see you in the next one. Bye, guys.